This content is AI generated for informational purposes only and should not be directly used for clinical decision-making.
Hello and welcome back to the Neurosurgery Hub podcast. I'm Dr. Eris, a senior attending here, and I'm joined today by our research fellow.
And I'm Dr. Alara. Today we're looking at a fascinating new study from Scientific Reports, published in 2026. The title is A Cost-Sensitive Multiclass Machine Learning Framework for Postoperative Neurosurgical Triage, also known as the Neuro-TACTIC study.
This is a topic that hits home for anyone who's ever finished a long elective craniotomy at 6 p.m. and had to argue with the ICU resident about whether the patient really needs a ventilator bed or if they can safely go to a step-down unit. Triage is a constant balancing act.
Exactly, Dr. Eris. The paper points out that we're constantly trying to balance early detection of deterioration against these very finite staffing and bed resources. If we're too conservative, we overflow the ICU with patients who don't need it. If we're too aggressive with ward placement, we risk missing an acute hemorrhage or cerebral edema until it's too late.
Right. And historically, we've used our gut feeling or maybe some basic scoring systems. But as this paper notes, most of those existing models are binary. They just say ICU or non-ICU.
That's a huge limitation they address. Most institutions now have a three-tier system: the regular ward, the intermediate care unit, or IMC, and the intensive care unit, the ICU. Binary models completely ignore that middle ground where many of our post-op craniotomy patients actually land.
So tell us about the framework. How did the authors approach this differently with Neuro-TACTIC?
They developed a multi-class machine learning framework using an XGBoost-based classifier. They didn't just want to predict where a patient should go. They wanted a model that was cost-sensitive.
Cost-sensitive in the clinical sense, right? Not just dollars and cents?
Exactly. In this context, cost refers to the penalty for misclassification. For example, the cost of sending a patient who needs an ICU to a regular ward is much higher, in terms of patient harm, than the cost of sending a stable patient to the ICU, which is essentially just a resource waste. Neuro-TACTIC introduces a tunable parameter, they call it zeta, which allows a department to adjust the balance between over-triage and under-triage based on their specific staffing ratios or bed availability.
That's clever. It's a knob you can turn depending on how risk-averse your department is feeling or how many beds are open. Let's look at the data they used to train this.
They used a retrospective cohort of 1,072 patients who underwent elective craniotomies. To make the model robust, they pulled 27 different features across 3 categories: demographics, intraoperative data, and imaging-derived features.
27 features is a lot, but manageable for a machine learning model. What stood out as the heavy hitters in predicting where these patients ended up?
The feature importance analysis was quite revealing. The top predictors were operative duration, tumor volume, surgical position, body mass index, BMI, and the patient's age.
Those make sense clinically. A 10-hour surgery for a giant meningioma in a sitting position is a very different postoperative animal than a 2-hour convexity case.
Precisely. And by including imaging-derived features like tumor volume, they're capturing the complexity of the pathology itself, not just the patient's comorbidities.
Now, let's talk numbers. Machine learning papers often look great on paper, but fail when they meet a new set of patients. How did Neuro-TACTIC perform?
They tested it in 2 stages. In the development cohort, at their chosen operating point of zeta equals 0.975, they saw an AUC sub M, the multiclass area under the curve, of 0.67 and a weighted F1 score of 0.49.
0.67 for the AUC. To our residents listening, that's fair performance, but it's not perfect. It shows the inherent difficulty of predicting these outcomes. Did they validate this on an outside group?
They did. They used an independent evaluation cohort of 81 patients. The performance did drop slightly, as expected, to an AUC sub M of 0.60 and a weighted F1 score of 0.44.
That drop-off is common, but it highlights that this is still a proof of concept, as the authors state. But what I find interesting is the stability. They used repeated cross-validation and bootstrap analyses, and the framework showed stable behavior across those cost settings.
And that's the real strength here. Unlike a static risk score, like an ASA score or the HANA criteria, Neuro-TACTIC allows you to visualize the trade-offs. If you want to ensure you never miss an ICU-level event, you turn up the zeta parameter. You'll have more over-triage, meaning more stable patients in the ICU, but your under-triage rate drops significantly.
It's moving us away from one-size-fits-all triage. In a busy Level 1 trauma center where ICU beds are like gold, you might set that threshold differently than in a smaller elective-only center.
Right. And the paper explicitly mentions that previous models collapse this into ICU versus non-ICU because they lack a mechanism to tune these thresholds to local definitions of ICU-level events. Neuro-TACTIC bridges that gap.
Let's dive a bit deeper into the intraoperative features. You mentioned surgical position. Did they elaborate on how that impacted the triage?
While the model uses XGBoost, which can be a bit of a black box, surgical position is a major factor in neurosurgery due to the risks of air embolism in the sitting position or the physiological changes associated with prone positioning. Combined with operative duration, these features capture the physiological stress the patient underwent during the procedure itself, which is often a better predictor of immediate post-op needs than preoperative status alone.
I also noticed they mentioned tumor volume specifically from imaging. That's more precise than just saying big tumor or small tumor.
Exactly. It's an imaging-derived feature. In the era of digital health, being able to pull that volume data directly into a triage algorithm is a major step toward automated decision support.
Now, for our residents and students, we should be clear about what this study isn't. It's not a tool we're using in the clinic today.
Correct. The authors are very transparent about that. They call it a methodological proof of concept. They emphasize that before this can be deployed clinically, they need prospective validation, meaning testing it in real time as patients come out of surgery, and multi-center evaluation to see if the model holds up at different hospitals with different patient populations.
And that independent cohort of 81 patients was relatively small compared to the training set. It's a good start, but we need more data to see if that AUC sub M of 0.60 can be improved or if it represents the ceiling for this kind of retrospective data.
Another point the paper makes is about the asymmetric costs. In a regular binary model, the computer thinks a false positive and a false negative are equally bad. But in neurosurgery, sending a patient with a brewing epidural hematoma to a ward with 1:8 nursing ratios is a much bigger cost than keeping a healthy patient for one night of observation in the IMC. Neuro-TACTIC is one of the first frameworks to bake that clinical reality into the math.
It's the safety-first mentality of neurosurgery translated into code. So, Alara, if you're summarizing the take-home for a busy resident, what would it be?
I'd say the take-home is that the future of postoperative triage isn't just a binary choice. The Neuro-TACTIC framework shows we can use machine learning to handle a 3-tier system: ward, IMC, and ICU. And more importantly, we can tune the model to fit our hospital's specific resources and risk tolerance.
And for the attendings out there, it's a reminder that factors like BMI, age, and especially surgical duration and tumor volume are the key variables that the data shows truly drive postoperative care needs.
It's really about moving toward a more nuanced, data-driven approach to patient safety.
Well, that's all the time we have for today. Fascinating study. We'll be watching to see if the prospective trials for Neuro-TACTIC come through.
Thanks for listening to the Neurosurgery Hub podcast. We'll link the full study from Scientific Reports 2026 in the show notes.
Until next time, keep learning.